Hello, and welcome back to Educator.com and this series on AP Computer Science. The topic of today's lesson is input, output, and errors. In today's lesson, we'll first talk about getting input from the user. We'll talk about providing output to the user. We'll then talk about special characters, how we can use escape sequences to print special characters that we would not otherwise be able to print within a quoted string. And then finally we'll talk about error handling and exceptions, which is really the art of dealing with the unexpected. So let's jump right in. Getting input from the user. There are many methods of obtaining user input, and these tend to be platform dependent. For the AP questions, the College Board did not want to have platform-dependent questions where your answer might be different depending on what Java system you're using or what type of computer platform you're using. So what they will do on questions that require user input, they will show one of two things. They will either show a variable, and they'll tell you the type and name of the variable equals, and then they'll have some kind of comment like this: call to a method that reads a floating point number. And you should just assume that some method is going to be called on this line, and the result of running that line will be that a floating point number entered by the user has been stored in this double called x. Or they'll give you something like this: double x equals, and then a comment, read user input. And these should be treated as equivalent to one another. Don't concern yourself with how the user actually would provide that input. Simply know that when this line finishes executing, this variable will contain a value that was obtained from user input. So specific methods to read the input are not in the AP subset. Also, converting strings to numeric values are not in the AP subset. There is a way that you can read in a string and parse it into different values, but that is not something that you're expected to know for the AP test. So if they want a double, they will explicitly tell you that we're going to read in a double. If they want an int, we'll read in an int, or a string, or whatever the type is. They would not expect you to convert that. Now, that being said, I do want to show you one method of getting input from the user, because you can do a lot more with your programs, and it's just a useful technique to know how to get input from the user. And I'll be using this in some of the examples in the class so that I can provide input to the programs that I demonstrate, and so I want to explain how this is going to work. There's a class called Scanner that was introduced in Java 5.0. So if you're using a current version of Java that's going to be greater than or equal to version 5.0, then you'll have this class available to you. And it simplifies console and file input. What we do is we import the library called java.util.scanner, and then we declare a scanner, and we give it a name, and we create a new scanner, and we pass system.in to the constructor for the scanner class. Then we can use this SC to read input from the user. So we read a string with the next line method of the scanner, and we store that into a string variable. We can read an int with the next int method and store that into an int variable. We can read a double with the next double method. That has to be stored in a double. And we can even read a Boolean. There's a next Boolean method, and that gets stored into a Boolean variable. So I'll demonstrate all of these in just a minute here, but I first want to talk about providing output to the user, and then I'll demonstrate both input and output at the same time. Just as there are many methods of obtaining input from the user, there are also many methods of producing output. And once again, the College Board, the people that produce the AP tests, did not want to have any kind of platform dependencies on test questions. So the only two methods of producing output that are included in the AP subset are available universally on all Java systems on all platforms. And these are system.out.print and system.out.println. Print will print whatever is passed to it in parentheses, and then the next output would continue right there on the same line. Println will print what's passed to it in parentheses and then advance the cursor down to the beginning of the next line so that the next output would begin on the next line. That's the only difference between the print and the println methods. So here's an example, printing two strings on the same line. String 1 is hello and string 2 is world. And if we call print on hello and then println on world, the output of S2 would continue where the output of S1 left off because we use print, not println. So it would print hello, comma, space, world, exclamation point, all on the same line. We can print two or more values together by combining them into one string with the plus operator and passing that to the print or println method. So we'd say the number is plus I, and then that would print the number is 100 because we've assigned 100 to I on the previous line. If we want to print a blank line, then you can simply call system.out.println with nothing in the parentheses, and that will print nothing except a blank line. So for formatting output, maybe we want to have a blank space in between some groups of output. This would be how to do that. So let's take a look at some Java code that gets input from the user and then produces output. So here's a simple example. I'm going to print, please enter your name, and the cursor will wait on that line, and I'm going to use the next line method of the scanner class to read in a string and assign it into the variable my name. And then I'm going to use my name and say hello and print the value of my name with a period. I'm going to use print line, so that will advance the output to the next line, and then it'll say nice to see you today. So let's run this. It's prompting me, please enter your name, and I will enter Tom and hit enter. And it used the value of my name that I just typed and says, hello Tom, nice to see you today. So that's a simple example showing both input and output of string data. Going to uncomment the next section. Now I'm going to show reading in integer data. I'm going to prompt, how old are you? And it will accept input of an int and then print a statement using that int. So how old are you? And I'm going to cheat a little bit and say 21, enter, and it says it's hard to believe you're 21 years old. So that's an int. Comment that section and uncomment the next section. And this is a technique that you can use when you only want to run certain portions of your code. You surround the portions that you don't want to run with these comment symbols and remove comment symbols from the portion that you do want to run. And this is a good technique. I'm using it for demonstrating different portions of the code, but it's also a good technique if you're trying to troubleshoot your code and see why certain sections of the code don't seem to be doing what you anticipate that they would do. You can comment out all but the one section that you want to run and try to see what's going on. So in this case, now I'm going to declare a double, my account balance, prompt what is your account balance, read in that double, and then print that out as part of a statement. So what is your account balance? I'm going to put 123.45. And it says, lucky you, you have $123.45 in the bank. So that is reading in and outputting a double. Last one is going to be a Boolean. So notice I always prompt the user to guide them to produce or to enter the type of input that I'm expecting. Enter true if you know where you are, or false if you are lost. And I know right where I am, so I'm going to put true. And it says you entered true. And it echoed back the value of is found using the print line statement. So that is how we read in and how we output values of all of the various types: string, int, double, and Boolean. Let's talk now about escape sequences. This technique provides a way to include special characters in a string. And an escape sequence is a backslash character. That's not the slash on the question mark key, that's the other slash facing the other direction. If you're a Windows user, that's the slash that you would use to indicate a path separator in a Windows or MS-DOS file system. Backslash character followed by one or more additional characters. Now if we want to put a new line character, that is, if we want to print something and then go to the next line before we print more output, we put a backslash n, and it needs to be a lowercase n. So we declare a string called greeting, and we say hello, and then a backslash n, and then world. And if we print that, then it will print hello on one line, treat the backslash n as a new line, go to the next line for the remainder of the output, which is world. Notice I don't need to put any blank spaces before or after the backslash n. It will correctly find and interpret the backslash n even if it's adjacent to other characters in our string. The next escape sequence is for the double quote character. Because the double quote character is the delimiter for strings of text, we can't just put a double quote in the middle of a string of text. The compiler would interpret that as the end of the string of text, and we would get a syntax error for whatever follows it. So if we want to put a double quote character within a string of text, we use a backslash and then a double quote. So in this case, I declared a string called name, and I want to print a double quote character before and after this part of the name. So I have still a string of text with a regular double quote character at the beginning and the end, and then where I want the double quote to appear within the text, I use a backslash double quote in these two places, and that will print that correctly, as we'll see in just a minute. If I want to print a backslash character, I need an escape sequence for a backslash character because the backslash character indicates the presence of an escape sequence. So if I want to print a backslash, I can't just use a backslash. I need to have a backslash followed by another backslash, and that is how I print an embedded backslash within a string. So if I have a folder name and I want it to have these backslashes to indicate the path name separator in the Windows file system, then I would use two backslashes there in each of those places. Java does provide other escape sequences that are not included in the AP subset. So these are the only three that you need to be aware of and be comfortable using. So let's take a look at printing some text with some escape sequences in it. And these are exactly the same three examples I had on the slide. I have hello world, where I want a new line character between the hello and the world. I have Sean Diddy Combs, and I want to put the double quote character around the name Diddy. So I use the backslash double quote as the escape sequence to tell the compiler this double quote is not the end of my string. It's a double quote that I want to appear within the string. And then to print the backslash character as part of this file name, I use the backslash escape sequence. So let's run this and just verify that those output as we expect. So here's hello, followed by a new line, followed by world. Then the second one using the escape sequence for double quote, look, it's Sean Diddy Combs, and it puts the backslash, or puts the double quote character around the word Diddy, just like I wanted it to. And then the third output, copy the file to the C Windows System 32 folder, and it printed one backslash here for each of the double backslash escape sequences that I put within the string. So it did produce exactly the output that I wanted it to. Final topic for this lesson is exception handling. Exception handling I like to describe as dealing with the unexpected. Because people who you don't know are going to run your software, if you write software that other people use, you need to anticipate that things will not always go as you expect. And exception handling provides a structured way to handle errors. If someone provides input that is in a format that you're not expecting, you don't want to just have your program crash. That's considered not very good. So you want to do something better than that, which is to provide a graceful handling of unexpected situations. And exception handling provides that. There are 6 exceptions within the AP subset. There's the arithmetic exception, which would be, for example, dividing by 0. If you prompt the user for a number, and then you use that number as the denominator of a fraction, and if they happen to type 0 as that number, you would be dividing by 0. And that's not something that you can determine when you're writing the code, because you're asking the user for input, and they can input any value that they decide to. So this would be an example of an arithmetic exception, and I will demonstrate this in just a minute after this slide. There's also array index out of bounds. If you try to go past the end of an array, so if you've declared an array of size 10 and you try to get something, some element out of the array that's greater than 10, you're going to get an exception. Class cast exception, if you cast something in a way that's illegal, you're going to get this. Illegal argument exception, if you pass an invalid argument to a method, you may get this. Index out of bounds exception, and null pointer exception. So you should be familiar with these 6 exceptions. An unchecked exception means that your program terminates. It will produce a message in the console window saying that an exception has occurred, and the program simply terminates at that point. A checked exception is where you provide code to handle the exception. So instead of simply allowing your program to terminate, you can write some code that may do something like write a message to the user saying that something happened, or allowing the user to try again with different input, for example. And you need to know what triggers each type of exception. So let's take a look at the example of an arithmetic exception and take a look at an actual Java program running that is going to throw an exception. We'll comment out the escape sequence code and uncomment this code here. So what's going to happen here is I tell the user I will perform division for you. I ask them to enter the numerator, and I get the next int, and then enter the denominator, and I get the next int, and then I divide the numerator by the denominator. So if you see where I'm going with this, as long as they don't enter 0 for the denominator, I'm okay. But if they enter 0 and I attempt to divide by 0, that's going to throw an exception. So let's first look at the desirable functioning. So let's say the numerator is 8 and the denominator is 2. The result of the division equals 4, and that's exactly what I expect. Now, I'll run it again, and this time I'm going to try to divide 5 as the numerator and 0 as the denominator. And what happened is it tells me in red letters here that an exception occurred in thread main. And it tells me that the exception type is the arithmetic exception and gives further details that says it was a divide by 0 error. This symbol here is the division operator, so it's a division by 0 error. And it even tells me the line number on which this error occurred. So that would allow me to go into the code and fix it. And what I might do to fix it is to put some kind of a check after I read the denominator to verify that it's not equal to 0 before I attempt to do this numerator divided by denominator calculation here. So in a real-world program, I would always check if the user input is in the expected format. But since I didn't, it allowed me to demonstrate the arithmetic exception. So that's what it looks like when the Java system throws an exception. So to summarize this lesson, we first looked at getting input from the user. We talked about that although the AP Java subset has no official means of getting input from the user, they're going to give you a comment that says that the user is going to provide input in the form of a double or an int or a string or whatever they need. I did demonstrate the scanner class, which was introduced in Java 5.0, and showed how to use that to read strings, ints, doubles, and booleans. And that will be very useful to you in writing your own code that will give you a lot more flexibility in being able to write a wider variety of different types of code. We then looked at providing output to the user and the fact that the system.out.print and system.out.println are the only two methods that are in the AP Java subset. So all of your output for all of your AP exam questions is going to be text output. There will be no graphical output that you'll need to produce. We looked at the special characters, the escape sequences, to insert either a double quote character, a backslash character, or a new line character into your string output. And then finally we looked at error handling through the exception mechanism, dealing with the unexpected, and we saw an example of an exception being thrown. This concludes our lesson on input, output, and errors. Thank you for choosing Educator.com, and I look forward to seeing you on the next lesson.